everyone. Today, our team is going to walk you through our project on credit card fraud detection. So in the following 5 minutes, we will present the problem itself, how we handle our undersampling data with four models, and we will also explain why Random Forest ended up being our MVP for catching fraud. So our main goal wasn't just to build another model, but also to create a system that can actually works in the real world. So especially by tackling some of the biggest headache in the financial data, which is extreme class imbalance. Credit card fraud detection is challenging because fraudulent transactions are extremely rare. There are only 0.17% of our data. So if we train a model naively, it will just predict no fraud for everything and get a high score, which is useless. So let's begin with why does this matter? Well, almost everyone here has dealt with a fraud alert before. So it's a massive problem that affects half of the US adult and costs billions every year. So because of the transaction happens so fast, humans simply cannot keep it up. So this is why machine learning isn't just a fancy tool here, and it is a total necessity to keep our money safe.
So we use a real-world dataset from European cardholders with about 284,000 transactions, but only 0.17% are fraudulent. And also to protect privacy, the original features were transformed using PCA, so meaning that we focus entirely on predictive performance rather than feature interpretation. And the core challenge we faced was with such extreme imbalance, a naive model could achieve over 99% accuracy by always predicting not fraud. And that makes accuracy misleading. So we rely on metrics like AUC and confusion matrix to properly evaluate performances.
To address this unbalancing issue, we applied random undersampling to the training data, creating a balanced dataset. This forced model to learn meaningful patterns instead of defaulting to majority class. And for some data exploration insights, the PCA variable show low correlation by design, reducing multi-collinearity concerns. And we also observe strong skewness in transaction amounts, which reflects real-world spending behavior. And for the model we used, we applied logistic regression, decision tree, k-nearest neighbors, random forest, and all models were tested using accuracy, AUC, confusion matrix on the test set.
First of all, we have applied a logistic regression. It builds a strong and interpretable baseline with high AUC score and accuracy. And next, we have applied a shallow decision tree. It actually matches the logistic regression accuracy while maintaining transparent and easy to explain. After that, we have applied a KNN. It helps to minimize false positives, but it actually suffers from high false negatives, meaning it misses too many fraud cases. And lastly, we have applied a random forest, and it actually achieves the best overall performance with the highest accuracy and AUC score while maintaining a strong balance between false positives and false negatives. So overall, the random forest outperforms all the other models across key metrics, offering the best balance between detection power and robustness.
So the trade-off between predictive power and interpretability, simpler models like logistic regression and decision trees are easier to expand and audit. However, random forest delivers superior predictive performance at the cost of interpretability. The optimal choice depends on whether performance or transparency is a top priority. Let's look at the real-world deployment. In practice, fraud detection system must be continuously updated, carefully tune classification thresholds, and balance regulatory needs with performance. In the end, our study shows that ensemble method, particularly random forest, provide a powerful and practical solution for real-world fraud detection. Thank you.